Hey everybody, Adam Savage here in my cave with some Blade Runner goodness. Back at the very beginning of lockdown, RPF member Dietz, D-E-E-T-Z, started a build of Sapper Morton's helmet. That is Dave Bautista's character in the beginning of Blade Runner 2049. The first time we see Sapper, he is farming nematode worms in the dystopic future of the Blade Runner universe. And he's wearing this elaborate costume. And Dietz did a beautiful build. It was a commission. And later on, that commission came up for sale and I bought it. I have to, first off, just give the most emphatic compliment to this helmet. I have crawled over this thing in great detail and I have yet to find anything that is wrong with it. It is really, really accurately built. This neck bellows is chef's kiss perfect. It is really rare when you get a piece and you like I'm looking at photos I have from reference, etc., and I'm trying to find anything that's wrong, and nothing's wrong. Even the paint job is this is a stunning piece. And so I want to make a whole costume. What I want to start with is at the back of the helmet, he's got this airline that connects to his suit, presumably. And we see on the back of his suit these two large vents. So presumably those vents draw air in, or they filter it, and they filter it to the helmet, something like that. I want to make that piece. Now, I did some screenshots. I took the, what did I do? I bought it and I streamed it online and I did some screenshots and I did some close-ups. And here is where you can see the kind of structure of this. It is a caged tube and the cage is composed of sections of octagonal material. Here is a super close-up of one section. So you can see that there's like a pivot here. And then that pivot turns 90, and now it's here. And on the next link, it turns 90, and then it's there. So what it allows for is a 360 flexibility for a part where all the pieces are identical. I will tell you, I spent a long time thinking this was some sort of turnkey operation or some sort of product that I could buy. I looked up armored cabling and stuff, couldn't find it. So I'm assuming that is a 3D printed part. I get a lot of questions about why I don't use a 3D printer more often here in the cave. I'm doing a work for hire right now, and I sent a 39-hour print to that printer a few days ago, and last night I checked on it and had 8 hours left, and it was going great. And then this morning I came in, and the uninterruptible power supply had failed. The wall power was good. My UPS failed. The extra insurance turned out to be my liability on this 39-hour print. Crap the bed with like 4 hours left. Look, I know that my labor in that print is much lower than 39 hours, but frankly, in a mission critical job, I can build what I was printing way faster. I could sculpt it from scratch. Anyway, that's just me complaining. Me working now will involve me making this armored pipe out of aluminum. Let me show you. Okay. It's fine. Everything's good. I went looking and I found one piece of octagonal aluminum with what I believe is a sufficient wall thickness for me to hand machine all 20 sections of this. And then also I'm going to make the receiver port. I'm going to make the receiver port on the back of the suit. Eventually I'll make the other parts of the suit, the neck ring, etc. There's the neck ring. That's a pretty straightforward part. I'll probably make that out of Ren shape. So, I've been making drawings. Now, drawings here are not necessarily mission critical for the problem. But sorry, they're not mission. How do I say this? This is kind of how I work through a problem and kind of understand it. That's the goal here. So these drawings are less engineering drawings than just a sort of a way for me to wrap my head around this. And now I think I understand it. I think I've got it. So I'm going to start making some cuts. Yeah, I've even drawn out my order of operations there. The main thing about this is I need 20 pieces out of this, and it's only 36 inches long, give or take. So I have to be economical. Also, there are some, anyway, there are multiple parts to cutting this. Multiple arrangements. There are a lot of steps to machining out 20 of these. First, there are these in cuts here that like cut this material away and down closer to the ID. Then there is cutting them to the length. Then there's removing all the material except for the tabs on one side, and then the same opposite 90-degree tabs on the other side. Then there's drilling the holes in the tabs. Then there's radiusing the tabs. Then there is thinning out the tabs, both on the outside and the inside, so that they can marry together. Then there's adding the pivot screws, which I think are going to be 440 or 632 button heads. I don't know what they have here. Actually, it looks like it might even be rivets on this, but I'm going to do button heads. There are a lot of steps to this, and there's a lot of ways I could get this wrong. So it's just a careful, slow machining process here for this. 1.25 plus kerf. All right, I should be able to get 6 out of each one of these. Right? 1, 2, 3, 4, 5, 6. Great. That's 6, so that's 24 total. I need 20, so I'm making 24 so I can screw them up. So I can screw a few up and get it working still. It up. All right, let's see if I can rescue this. Oh, that bit is ugly. I messed up. See if I can get the gall off here. So I wanted 20 connectors. I ended up with 21. I thought I'd cut these on one of the bandsaws. The only issue is the bandsaw wasn't cutting straight, and I needed these to be nice and perpendicular in their cuts. So I used the table saw, but it was a bigger kerf, and I ended up losing 4 pieces because of that. And I screwed up a cut, so I lost 2 more pieces. I now have 1 buffer. I have 21. I have actually 2 more buffers if I need them, because where it comes out of the helmet, I don't think it needs to be a full piece. It could just be a half a piece, and the same thing with where it goes back in. So I could adjust with some of the off cuts I've ended up with. But so right now, what I'm going to do with these is I'm going to cut in and leave only the tabs. They won't be rounded at this. You'll see. I'm going to make the next cut in all 21 of these frickin' pieces. Yeah. One thing I'm noticing about my skills is that I'm getting better. I'm getting better at holding on to stuff, like knowing how tightly. And these parts are difficult to grab. They squish, and I have to accommodate for that. And experienced machinists can see I'm playing a little fast and loose with this, because the tolerances are aesthetic. So like if the mechanical operation of this was completely mission critical, I'd very likely be taking twice as long to do it. But despite having made a couple mistakes, I'm really pleased with how this is going. I'm going to end up with 21 good parts, hopefully. And here, by the way, here's the, okay, so here is the part as it stands. So now what needs to happen next is that half of these tabs get half of the material taken out on the inside, and the other half get the material taken out on the outside. That's the operation I'm nervous about. That's the one that's, yeah, I still haven't figured out how I haven't figured out how I'm going to hold on to it yet, because I'm just moving forward with just getting this part done. You know, I now have enough machining experience to kind of, it's funny, the more experience you have, the more you're able to cut corners where necessary. That's really what experience is about. It's literally about knowing how to prioritize the decision tree. And there's so much more than just the part is perfect on that decision tree. There are all sorts of other considerations, but only experience kind of gets you there. Okay. And I keep my finger here just to feel as I'm moving if I feel any movement in the jig. And I know. But if you were feeling what I'm feeling, you'd feel comfortable with this too. This is a aluminum specific bit, an Alu Power expensive aluminum end mill, 3 flute. And boy, I love the way this thing chews up aluminum. It is just, it's a beauty. And notice, I'm not making a second cut on the other side. I'm constantly turning these because the back side of your vise should always be your reference. Sorry, that's what I've learned, is that I do better when I use the back side of the vise as reference. These things all squish a little bit. And if they squish, and I squish more on one than the other, then when I make the second cut, it could all go cattywampus. I don't mean to get technical on it. This step of using a little brass hammer to seat everything, oh my God, it is such an important step. We're on the home stretch now. One more set of 4 after this, and then I get to worry about how to hold on to these while relieving some material. Then I have to radius them all. All right. There we go. So this spins this way, and a climbing cut is that it is moving in the direction that it's cutting. Yeah. Okay. Then we're gonna secure it down. Tight, hammer, tight, hammer, tighten, tighten. Pretty good. All right, here we go. The inside tabs have been cut out on everything. I think the next step is some hole drilling. They're coming along. Still a lot of work to do. Still a lot of lines to see. But it's too cold and old and settled in its ways there. Old California. I'm taking out a little material. I know it's not pretty. Doesn't need to be. And it doesn't even have to be exact. I'm just trying to clear a space so that this can actually rotate in there. Later I'll radius this. We're almost there. Woohoo! One parts, and these pieces, they're together. Oh my God, I know. This side doesn't match that side. I don't care. This was quick and dirty. This is 21 custom machine pieces, each with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, somewhere just shy of 20 operations per piece times 21 pieces. It's 2,400 separate operations, and it's a one-day build. So I am okay with a little bit of slop. So now I have a protocol. I'm going to start rounding these. And I'm going to do this, the poor man's blue, just because it's faster. I'm going to use the magic marker. And then I'm going to take the compass here. There we go. That's what I'm going to cut on. That's what I'm going to sand on. All right.
All right. They're pretty. They are pretty.
I just drooled. I literally just drooled. I was making fun and I was having fun and I drooled a little bit. A key moment in the machining of a bunch of little objects like this would be the deburring stage, the final finishing stage. And I'm going to streamline that by using a parts tumbler. What? Yes. Hang on. This was a fun build. I know. Look, I'm so aware that like people are watching this being like, oh, that's a C-147 hose protector. And there's others who are like, why didn't you 3D print it? And I've already said, for me, this is an exercise and it's a really fun one I find enjoyable. I've been thinking about it for weeks. But I'm not cleaning up just yet. So a parts tumbler is literally a vessel in which you put your part and you put some media with that part, and then you roll them so that the part gets tumbled around in the media. And the media that I am using today is ceramic. Ooh, ceramic, there you go. The ceramic media bangs around with all of these and slowly just like takes the burr off. It's really lovely. It also leaves a kind of, you see how I have a difference between the as-bought finish and my milled finish? It eliminates all of that, all those maker's marks, actually. It's a lot of parts. It's going to tumble all night long. It's going to tumble all night long. All night long. Here is my parts tumbler, and this is ceramic media. And in general, you run it with a little bit of water. I'm going to add a little more to this. 1, 2, 3, 4, 5, 6, 18, 20, 21. And there's 2 bad ones in there. And unfortunately, they're both bad on the same degree, so they can't both end up being a mounting point. Look, it ends up being that I might get 18 or 19 out of this. But so let's see here. I add a little bit more water. Yeah. Then a gasket, a trasket. My tumbler gets a basket. A gasket for my basket. Okay, then a aluminum plate goes over it, and we go and we tighten it down. I picked this parts tumbler up a few years ago on Craigslist, and I used it a bunch during the Hellboy Samaritan build. I use it a lot off camera, I must admit. And I have an idea for it that I've been meaning to do on camera, but this will have to be your introduction to this phase. So in general, hand tightened, and it doesn't leak. So then we put it in its carriage. Looks like this. Let's pop it in like this. These rollers keep the wing nuts from crashing. And that's it. I'm just gonna make sure it's super tight. I actually built I forgot about this. I built a wrench for tightening these. Excellent. Oh, much better. All right, good. Now I'm positive it won't leak. Yeah, there we go. I'm very excited about what you get to see in a couple minutes. All right, I'm going to clean up. Okay, it's the next morning, and as you can hear, the tumbler is going. We're gonna turn it off and open it up and see what treasures are inside. I always also kind of secretly imagine that when I open this up, all the parts that I've made will somehow be destroyed in some way. I'm like always half expecting that to be an outcome. I'm going to go put on some rubber gloves because it might be dirty. It's gonna be dirty. It's warm. I can actually feel the temperature. Ooh, foamy. I'm going to get out the parts washer. All right, let's we'll take a look. It's all very new. Ooh, whoops. I want to keep all the media. Oh man, it's disgusting in there in a fantastic way. 3, 1, 2, 3, 4, 5, 6, 21. The reason this is yeah, that should be it. The reason this is a bit blackened is specifically because at some point in the recent past, I threw in some lapping compound. Sorry. Yeah, the lapping compound is oily and disgusting, but it lent a really neat finish. Here's the parts fresh out of the tumbler. Very excited. Let's put them in the parts washer. Oh, I already turned it on. Whoops. Hilarious. Oh, I can't wait to assemble this. All right, we're gonna assemble. Here we go. Oh, like little jewels. Oh, super exciting. All right, that's a fix for later. I made the choice here to thread the outside of the two holes, not the inside, and then I don't have to worry about tightness, right? Because it's just poking through, right? So I can tighten it on the outside. Yeah, anyway. Oh man, this is starting to be amazing. My only fear is it's not long enough. Dude. That is freaking awesome. That is without a doubt the most complicated mechanical thing I have ever built. All right, I made one last little part for capping to the other end. So this is the base and this is the top, or vice versa. And I'm about to attach this and we can call this project completed. Ooh, child. Oh, hey. Good morning. All right. I am a very happy camper this morning because of this. Look at this beautiful thing. Oh, 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 yeah. Oh. Very satisfying sound. And I'm so sure that this exists, right? Like there's a product and I just wasn't able to find it. And as soon as this video goes up, y'all are gonna point me to it. Either that or someone in Doug Harlocker's shop carefully 3D printed all these sections and then assembled them and thinks it's crazy that I machined this. Or somebody machined this. That part I doubt. This might be the first one of these that has been machined. Or it's the millionth and there was no need for me to go through all of that. Also, my figures for the number of individual operations, I don't know. There's 25, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 22. 20 plus the two ends. And I need to make its interface here. Yes, yes, right. Is that an actual inlet? Oh, so it is. So we could get air up in through there if we wanted to. All right, so I'm going to make a little coupler tube that goes from here into here. But first, let's look at this a little more. Oh. That's my ASMR. I've made this little coupler, a couple of passes on the lathe. Gonna deburr it. And then this is my piece at the helmet. Oh, I'm gonna have to actually pressure that on. This fits nicely here in the back. Oh, I want to radius that edge. Damn it. Yeah, better looking. Yeah. So then this piece, where is it? This piece, which is the start of the chain, press fits onto there and allows it to begin. Oh, yeah. Look at that. She's so pretty. Just doing a little CA glue to hold this on. It's not going to be under a lot of stress. Just there. Woo! So exciting! I'd like this to be black, so I'm actually going to try a little aluminum black, some gun blacking. All right, so I'm going to clean first with some acetone, and I may need some more. Oh, so I see the anodized coating on the outside of the aluminum stock is actually not taking the black, which is fine. Again, I'll hit that with some black paint. All right, now I got this tiger stripe. I'm going to hit this with a black lacquer, and that'll be the thinnest paint. Yeah, that'll be the way. It is the way. The paint I'm going to use for this is Floquil Engine Black. The reason I'm using lacquers is they're durable. For stuff like this mechanically, I don't love using spray paint because it's so dimensional. It has such a thick coat, and lacquer can go on exceedingly thin. I gotta build myself a painting area soon, a real painting zone. This is getting out of hand. So, has a coat of lacquer. It all looks a little too new. Yeah, you see how smooth those are? And if we take a look at the screenshots, I can see some heavy texturing there. So I'm going to add that. And I'm going to add it with a little black acrylic paint, sort of hand applied. I'm putting it on sort of dimensional, so it's going to take a little bit to dry. Just this one line. Here we go, another one. Once I'm done with this, I'm going to hit it with a little bit of some rust color just to give it a little bit of visual texture. It shouldn't just be completely black. I want a little brown in there as well. The nice thing about acrylic is when you put it on dimensionally, it doesn't shrink as much when it dries. So you do actually get some texture. And we're back to the front. So now I just spin it, kind of looking for stuff that catches my eye or doesn't. Some of the screws are working their way loose a little bit. Just bringing them back in. threading the outside of these two tabs instead of the inside was it's not a common solution for me. I'm really happy that I did it. It's got a very positive grab. But also you don't have to finesse every single screw in order to get it. Okay. A little rust from Archive X here. Look, I shouldn't finish this video without talking about the incredible work of Renee April. I think that's how you pronounce her name, the costume designer for Blade Runner 2049. She's an amazing costume designer. In fact, has worked on a lot of films I really, truly love, including way back earlier in her career, working on Quest for Fire, a super early Ron Perlman, Ray Don Chong movie with not a single line of dialogue in the whole thing. And it was on HBO constantly when I was like 11 or 12 years old, and we watched it all the time. So funny that she was a wardrobe assistant on that film. But Renee April has been around longer than seems possible. Her film career goes back 30 years, which is astounding. Still working, still going strong, doing amazing, amazing work. And the world of Blade Runner 2049 is that Denis and his whole team built is really incomparable. And Renee April, I am a huge fan of her incredible work for her and her team. So I'm delighted to make a costume part for it. Okay. Here I get to show you this cool part. And I think this is where we wrap this up, because there's going to be a whole costume video. So here's the connector, and with a magnet, it connects in. Dude, he pulls that out. Yes! I know, I still have to put something soft inside there as the actual cord, but I view now, so I still have to make that part. This is all going to be for the Sapper Morton costume. That'll be a whole separate build. There's going to be some 3D printing in that and everything. But for right now, I have made the armored cable carrier of my dreams for my Sapper Morton helmet, and I think it is now officially completed. Oh, here we go. Ooh, it works with glasses. Hey everybody, this is Adam Savage, and I will see you next time. Oh, here, let me pull this out. Oh, look at that. I can totally reach it. I have to admit, I've spent a day now with this, and it feels good in a really, sorry, I guess what I want to say is 23 separate links, each with 18 operations. That's over 400 separate operations. And I ganged some of them up here and there, but still I was able to complete this in about a day. That feels like a real maturation of my machining skills. And I'm very, there are a lot of things I would have done if extreme precision was more necessary. I would have made a plug, so clamping these was a lot more of a positive situation. I didn't use a plug, so some of them got squished and some of the dimensions changed. I was aware of that at the time, and I had enough adjustability that I didn't have to really worry about that. And I built one link wrong. I came in today and I built one more link just because I wanted to see what it would be like to build a link from scratch. And I built that link, but you can see, it's two, whoops. Yeah. Maybe I'll make that one of the last links. Anyway. Oh, that's a nice light. There you go. Oh, look at this thing. It is just, it's so beautiful. And the degree to which it come on, there we go. Oh. Right? We're right in the Blade Runner world right there. It's deeply satisfying.